All right, today we're starting Chapter 7, so there was a typo, so make sure it says Chapter 7. It's called Congruence and Similarity. Congruent, same size, same shape, so similar must be something similar to that. And we're going to talk about transformation. So last chapter, basically, and this chapter kind of get combined, sandwiched together. This is the symbol for congruent. We talked about that before. And not the circle around it. The circle doesn't matter. But this little squiggle, that means it's similar. Okay, so looking at some of this real-world stuff, Braille. The letter R in the Braille alphabet consists of 4 large dots and 2 smaller dots in the pattern shown. Circle the letter with the same shape, so 3 big dots and a middle one. The only thing that comes close is Y or W. It's got to be W because it would be the middle one also needs to be a big circle. Neat word here, transformations. Translations, reflections, and rotations are called isometries or isometry. In an isometry, the distance between the points in the image is the same distance as the pre-image. Iso meaning same, metry meaning distance. So isometry, kind of a cool word. On slide 3, if you have 2 congruent figures, you can determine the transformation or series of transformation, meaning maybe more than one thing happened, that maps one figure onto the other by analyzing the orientation or relative position of the figures. So translation, the length is going to be the same, and the orientation is the same, it's just moved over. Reflection, the length is the same, but the orientation is reversed, or its position is reversed. In a rotation, the length is the same and the orientation obviously has changed. It's been turned or rotated. Usually about a fixed point. This one would probably be like here. They held their paper, patty paper here and rotated it. Here they reflected along this line, and here they just slid it down and to the right. So identifying if things are congruent or not. It says determine if the 2 figures are congruent by using transformations. Explain your reasoning. And then most of these we're just going to have to eyeball it. So besides the color, these 2 things are not dramatically different, so we're going to call them congruent. When it says explain your reasoning, I want you to tell me the types of transformations that would make these figures look the same. I want you to be very specific. Use those things like translation, rotation, reflection, and write congruent statements. I'm going to show you what that is, and usually we write those alphabetically. Just seems to be a little more helpful. So in this one, we would write that since these look the same, we would write triangle ABC, going alphabetical, is congruent, use that symbol, to A is, well, B and Y definitely go together. And so we have to decide if C goes with X or with Z, and they look the same here. So A has to go with Z. Triangle Z, and then the right angle looking thing, and then X. How would these have been congruent? Well, it looks like we flipped it over. What's it called when we flip it over? That would be a reflection. And then we translated it. So reflection and translation. Looks like translation. So in number 2, is A congruent to B? Just looking at it, we've got our bottom and then one to the side, bottom. These are not going to be congruent, so not congruent. We don't see this very often, but I guess we could do a slash through the congruent symbol. On the back, same thing here. Do these problems to find out, do A and B look congruent? They do. And there's no shape to write in front of a quadrilateral, so we would just go, this one, alphabetical, or the word bird, is congruent to, let's see, do B and B go together? Or do we need to figure out how would we get this onto here? So it looks like, to me, it looks like if we rotated this one, if I got my patty paper out, and we rotated that one 180 degrees, we might end up seeing exactly what we were going to do. So I'm going to prove that with some patty paper here. Here's my BIRD. So just a translation won't do it for us. A reflection? Reflection might do it for us. We could do that. That's one option. They land on top of each other. Another option, sometimes we get more than one, is that we could rotate this 180 degrees. Does that work? It doesn't. So the only thing that works here is to do a reflection. And what goes with B but A? And then it goes backwards. B-I-R-D, A-B-H-T. And what got us to get that mapped onto each other was a reflection. And then this is be a translation as well. A lot of these are going to be a translation at the end or at the beginning. You could translate it and then reflect, or reflect and translate. These two, again, the extra little spot is not in the same spots. These are not congruent. A few more things along these lines. Ms. Martinez created the logo shown. What transformation did she use if the letter D is the preimage and P is the image? Are the two congruent? They look the same size and same shape. Yes, they look congruent. What types of transformations would she use? Looks like she probably rotated this D and we got P. So I would say she used a rotation. Some of us might say she used a rotation and a translation. Rotation is a big one there. We couldn't reflect that one, could we? RD. Well, we could reflect it and then rotate it. Nope, not even then. So rotation is the best one there. So what transformation could we use if the letter W is the preimage? So this is our preimage. And the letter M is the image. Are they congruent? Do they look the same? Yes. Looks like we rotated it. So we take this M and we rotate, or we take the W, I'm sorry, and we get the M. Rotation. Now would this one be a reflection? Let's take a look. Here's my W. If I did a reflection, it would still be a W, so that would not work. So rotation, and again, you might say translation. Oops, I keep putting T's where there's none. Okay, a couple more. We write congruent statements, and we're done. Determine if the two figures are congruent by using transformations. So, do they look the same? Yeah, they do. So I'm going to go LMN, triangle. LMN is congruent to triangle. What would go with L? Well, I envision that this is a rotation. So, or could it be a reflection? Reflection? I think this week, if we reflected it here, I'm going to prove it with patty paper. If we reflect this along this line here, so we just bring it upside down, they would land the same. So I think that L goes with Y, Y, M goes with X, and N goes with Z. So I call that a reflection. You could do a rotation, but then your order would be different. Reflection and translation. If you did a rotation, let's just look at that. Where did my triangle go? L, M, N. If you do a rotation, we would need that L go with X, W go with, or M go with Y. So we have to switch those around. So you have to be careful about what you call it. So this one, if we did a rotation, would be triangle. L goes with X, and then Y, and then Z. Just be careful what you decide to do. Is this one congruent? S congruent to D? This one actually looks like it is, so S is congruent to D, and that looks to me like we just rotated about here, and potentially a translation again. So I'm going to write both just to be safe. And that's it for similarity. What is this one called? Congruence and transformations. It says, what is life? They say it's from B to D, from birth to death. But what's between B and D? It's a C. So what is a C? It's a choice. Our life is a matter of choices. Live well, and it will never go wrong. Have a great day.